Hi everyone, let's begin in this video two-way ANOVA. I had already explained you in my previous video how we have to run one-way ANOVA. So in this video, I will show you how you have to run one-way ANOVA as well as two-way ANOVA as well as interaction effect. So we would like to see how we have to report our results also. So let me open one new file. Here is, I'm going to open a new notebook, and after this we can see. So here is my one new notebook. You can see here documents, Python scripts and plot charts, right? I'm showing you how at the beginning, once you have to open, you can change your folders also, directory also. I had opened, this is my directory, documents, and in this documents, Python script. All the documents I have put it related to Python in this directory, in this folder, and in this plot charts. So again, I am going to create, there is one new notebook I'm going to open, and this is untitled. So let me give this title is, I'm giving this two-way ANOVA, two-way ANOVA. This is my new file, right? New notebook I had opened. Okay, fine. This is the, okay, already exists. So I'm just giving this two-way ANOVA 1. Let's say two-way ANOVA 1. So this is a new notebook I had saved. So first of all, what I have to do, I'm just mark down all those things. So I'm just putting up, here is hash, and now I am giving this is one-way ANOVA, one-way ANOVA. One-way ANOVA. So let me run this, and after that what we have to do again, first of all I'm going to import pandas as PD, pandas as PD. And after that what I will do, import stats model, same way, import stats model. I'm going to import stats models as API as .api as SM. It's very case sensitive, so make sure your all the words spelling should be correct. Otherwise, it will show you error, syntax error message. And after that, what I have to do from this particular stats model, what I want to run this ANOVA from this stats models dot formula dot API import what I want, import OLS. So simply, right, and I have done all these things. Now let me create a data frame. So this is my data frame. So in this data frame, I would like to open my file pd.read underscore Excel, because my data I had already put it in Excel file, and this file, make sure this file should be available in the same directory, otherwise it will not read. And my file name is two-way, my file name is two-way ANOVA. This is my Excel file name dot XLSX. Right, so let me open this file. Let me print this file, whether it is available or not. And data is there, yes. You can see here, when I had print this file, now you can see here, this is my variables. Salary is my dependent variable. Salary depend on education background and work experience. So here is, I have taken this case study. So first of all, let me explain you what is this case. You can see here, this is the ANOVA analysis of variance, two-way between groups ANOVA we can call it. And what is this example I have taken, this case study I have taken? An MBA aspirant was interested in knowing the impact of educational background. Educational background is one category is arts and commerce students, and another category is science and engineering students. So on the final placement salaries, we just want to know whether all both these groups salaries are same or there is any difference between salaries. So here is also aware that previous work experience has an impact on the salaries. There's the one more parameter we would like to consider whether those students have, those MBA students have previous work experience, they are getting more salary, or at par salary those do not have work experience. So therefore he chooses educational background and work experience as two independent variable. Based on educational background, respondents are categorized into two groups. And here is uh, basically one belong to the arts and commerce stream and the other belongs to the science and engineering stream. And based on previous work experience, respondents are again categorized into two groups, one with experience and the other without experience. Since we have two levels of each of the factors, this is called 2 by 2 design. So what I did in my this case study, a sample of 30 students is randomly chosen and their salaries from campus recruitment as well as information on educational background and work experience. For educational background, one represents arts and commerce and two represents science and engineering stream. Because both these are parameters, independent variables are categorical variable, where is I had assigned number. One I had given to those students, those are from arts and commerce background, and two I had given those students, those are from science and engineering stream. So for work experience, one represent students with experience and two represent students without experience. So salary is given in the multiple of lakhs. So you can see here these are the salary packages. On the in the last column you can see 8.50 means 8 lakh 50,000, 10 lakh, 9 lakh, 8 lakh, and you can see here students, total number of students data I have taken 30, and one stands for there is educational background, they are from arts. One we can see here is the educational background, right? And two stands for here is for science and engineering, and one is here work experience. If we talk about one means they do not have any work experience. Let me check. I think work experience, one represents students with experience and two represents without experience. So this is the salary package. So these are the two hypotheses that I want to check. One is the null hypothesis. The educational background and previous work experience have no bearing on the placement salaries of MBA students. And alternate hypothesis is the MBA students from science stream and or with previous work experience will get more salaries during final placement. So shall we now run in Python? We would like to check. I had already opened the same file in Python. And now what we have to do, we want to apply ANOVA, right? So let me, I'm just giving variable name is because that would be easy to remember this ANOVA. So I'm just calling this OLS function, and let me open this. These are the brackets, and here is what I want to check. This is a salary. Salary is a independent variable, and then that depend on, let me, I'm just taking for one independent variable, then it would be one way ANOVA. Here is educational background, and here is where is the data I had stored. This data it will pick up from this data equivalent to df, that is the data frame. You can see here I had given this df, right? So same is the data frame I had taken, and after that I am just writing here is dot ft dot fit dot fit, and I'm using these brackets, right? And after this what I will do, let me run this. I'm just let me run this, and after that, okay, fine, there's this some problem is here. What happened? Invalid syntax. ANOOLS salary, educational background and data equal to df dot fit. I'm sure this is the, okay, fine. Let me check where is the, I think there's the any function I have not defined. Let me check this. Let me check this. I think till here it's working well. This is also working. This is OLS is also working. And after that, ANOLS, I'm sure is the same. I had what happened? Invalid. I think there is the salary. I think same statement, SALARY, salary, and it depends on edu underscore back. And oh fine, I had not put it comma over here, right? So let me run this, right? Yeah, now it's performing, and I'm just print this. Let me no, before that I would like to give one more function over here. Let me store these values. This is the one way ANOVA, so one equal to, let me sm dot and stats, stats dot ANOVA and underscore linear model lm, right? And let me put these brackets, and where is this data? That is ANOVA, ANO, and what is the data type? Type is equal to, I'm just putting here 2, and let me run this. And now what I will do, let me print this, right? What is the value? Let me run this. Once again there is a problem. Okay, fine, because O is capital here. One is I had put it small. So now you can see these are the my values, and you can copy these values in your research paper, in your thesis also. We can see here educational background, degree of freedom is 1, and residual is 28. So some square is 1.8, mean square 1.8, f value is f statistics is 0.3767, and this is the value, p value is 0.54, and that is the greater than 0.05. That means this is not significant, right? So in this case, educational background, it is not giving any impact on salary. So now what we have to do after this one way ANOVA, let me, I'm just giving you, there is two way ANOVA, right? So let me pick up here is, we can see here, rather than this code marked down, and after that I'm just putting up here, I'm just writing hash. What happened? Let me mark down, and after that I'm putting here is, and I'm writing here, this is two-way ANOVA, two-way ANOVA, two-way ANOVA, and let me run this. After this we can see here two-way ANOVA. Now again, I'm what I will do, not writing again and again, so simply I'm just copying this particular function here, and after that control V, and now I am giving this particular is ANOVA 2, right? And data frame is same, and after that what I have to, again I will copy this function, right? And I will again rename this variable. I will say, because this is the, I'm talking about two-way ANOVA, simply I had given variable name is 2, and let me run both these thing, and after that let me check whether there is any difference in between these two. So I'm just printing this particular variable, and now you can see, oh no, sorry, I had not given, let me, I'm just deleting this, so another variable I have not added. So what I will do, we can see here, let me just here is, I would write it here, let me add another variable also. And what is my another variable? My another variable is, we can see here, in this case is, my another variable is, I had already printed this data frame. Let me print this once again, this data. So now what I will do here is, I would write it, there is the work experience, work underscore experience, EXP, work experience. So let me run this, and after that, once again, let me run this and let me print this. So what is work experience? It's not taken. uh, what happened? Let me check. Let me open my another file. Let me open my another file. Where is I had already I had given, there is ANOVA, right? Two-way ANOVA. Let me open this file, right? So now you can see that is I have run on the same, but here is everything is fine. You can see here ANOVA 2 and data frame. Let me run this, and after that 2, let me run this. Okay, fine. One mistake is here, right? Let me open this file one again, and now I will show you what will happen, what is actually not interpreting this my result, because I have not changed here this name. So what I will do now, I would run, now my results will be changed. Yeah, now you can see here, now educational background is not significant, but work experience is significant. You can see p value is 0.00033. That means it is less than 0.05. So work experience, definitely it is giving impact on salaries, but educational background is not significant. It is not giving impact on the salaries. So what I will do now, I would like to check interaction effect. So let me run this again. I will do markdown, and I will say interaction effect, and I'm just writing interaction effect, and after that let me run this interaction effect. And now what I have to do, I'm just using the same is I will copy over here, so I can modify this. Control C, and let me control V, and here is I'm giving this variable name is ANOVA 3, and I'm just writing here there is interaction effect also, and in this interaction effect we can see here again I will write plus sign. I'm just zoom it out, and after that I'm just interaction effect in between education underscore BAC K underscore background, and let me, and this is the interaction sign, then after that work underscore experience exp, and after that again right, and then enter this, and let me write the same thing, same I have to copy over here. Control C and control V, and again I would write, and here is I'm just writing, I'm just giving this file name is int interaction, and here is new file I had added interaction ANOVA 3. So let me run both these functions. What is the output of these functions? So let me print this int. Now int, let me print this, and what are my results? Wow, very nice, perfect results. Educational background is not significant, 0.419, that is not significant. Work experience is 0.00045, that is significant, absolutely. But educational background and work experience, when we are going to take together, that is again not significant, 0.700. So that means we can say these independent variables, they are not giving significant impact on our output or on our dependent variable. So how we have to, let me show you the same file. When I've run this file, we can compare this file with the statistical SPSS. When I've run the same file in SPSS, what were these results? I'm sure you can see here same results in SPSS, same results are in Python. So now you can see 0.701 interaction effect here is also, that is not significant. So how you have to report this result in your PhD thesis or in your research paper? We can see here F statistics corresponding to work experience is 23.896, which is significant at p value. right? P that is less than 0.001. F statistics for educational background is 0.243. There's a little bit difference. Those results we are getting through SPSS and we are getting through Python, so which is insignificant. But in both the cases, one thing is common: educational background is non-significant, but work experience is significant. So the interaction between work experience and educational background is also insignificant in SPSS, also in Python also. So therefore, null hypothesis is only partially supported, while the previous work experience has a significant impact on the placement salaries of MBA students. Their previous educational background does not. So result, how you have to report: previous work experience has a significant effect on the placement salaries of MBA students. F1 is 1, 26, and these are the values. And however, previous educational background does not affect the final placement salaries significantly. And here is, you will report both the values. The interaction of previous work experience and educational background also does not affect the placement salaries significantly. So I'm sure you understand how we have to run two-way ANOVA interaction effect in our Python. And we had already compared both the values with SPSS as well as in Python. So I'm sure you can run these code of commands right in your on your data. Thank you. Keep watching.